Hello, Honors Algebra 2. This is your second video of our Unit 0, and today we're going to be talking about functions and slopes of lines and graphing lines and all sorts of stuff. So we're going to start off with something called a relation. A relation is really just a pairing of input values or x values with output values or y values. So all of these are different types of relations. You could have a bunch of ordered pairs, you could have what's called a mapping, or you could have a graph. So what we're really going to focus on in this unit are functions. And one thing that has to do with functions is domain and range. Domain is the set of all inputs or x values. And the notation that we're going to use is something like this. This is called a brace, although I normally call it a squiggly bracket. And we put x, a colon. This means such that x, and then you're going to put whatever the domain is. So maybe it's greater than 7. Maybe it's not equal to 8, something like that. And then we close the brace. Okay, so the consistent part is you always have this, and then there's something after it, and then you've got the brace at the end. The range is the set of all outputs, which are your y values. And this is set up the same way. You have a brace, y such that y, and then there's some information after that, and then we close the brace again. This is something we will work a lot with in class, so don't worry too much about it for right now. Now, a function is something in particular. A function is a relation for which every input, there is exactly one output. Alright, so here's what this means. Each x can have only exactly one y value that it's going to. So let's look at each of these relations and determine if this is a function or not. There is 3, it goes to 5. There is 4, it goes to 5. 5 goes to 5, 6 goes to 5, 4 goes to 5. Now, all of these are going to 5, which is fine. What you are looking to do is to see if there's any x value that goes to more than one y value. You do have this, but they are the exact same point. So this is fine. This is a function. Now when you look at the mapping, this is a little different. -1 is going to 9. 0 is going to 8. 1 is going to 7 and to 10. That is bad. This is not a function. Each input can only go to one output. Okay. Again, input are your x's, so each x can only have one y value. So let's look, 15, just one y value. 15 and a half, just one y value. 16, you've got two different y values. Same with 17. Ooh, same with 16 and a half also. So there are lots of issues with this graph. Oh, and 17 and a half. So this is not a function. They are all relations, but they are just not functions. All right. So how can we tell if something is a function? Well, first of all, we said check to see if every input only has one output. There is another way. That is to check to see if the graph passes the vertical line test. So here's how you do the vertical line test. Basically, you are going to draw vertical lines through your graph. And if you hit any part of the graph more than once in a single shot, it is not a function. Notice my vertical line hit two separate points of the graph, so this is no. If you have an open and a closed dot, that's fine. The open dot doesn't count. Okay, it means you're not including that value. So that's fine. This is fine as well, open and closed. So you're only hitting one spot at a time. Even though technically you're hitting twice here, one of them is open. So this is a yes. Okay, draw some more vertical lines. You are only hitting one part on the graph for each vertical line. This is a yes as well. Okay, all right, so that's some information about functions for you. Let's go on. One type of linear function that you are probably very familiar with is a line written in the form y equals mx plus b. This is a linear function, linear for line. So in a linear function, you have two types of variables, the dependent variable and the independent. The dependent variable, shockingly, depends on the other variable. It's your output, and the variable is y in the equation y equals mx plus b. So that guy is dependent. The independent variable is the variable that's getting plugged into the equation. So since it's getting plugged in, it's the input, independent input, and it is the x in the equation y equals mx plus b. So function notation is something that we will work with a lot this year. This is pronounced f of 5. This basically means evaluate the function when x equals 5. So you are literally just plugging a 5 in here. F of 5 equals 7 times 5 minus 9. This is not f times 5. This is telling you what you're plugging in for x. And then you're just going to evaluate like normal. So f of 5 equals 35 minus 9 is 26. This is your x, this is your y. What this is really doing is telling you you have the ordered pair 5, 26 on this graph. Pretty cool. All right, slope, also known as rate of change. We should be familiar with this formula. Basically, slope is the ratio of the change in the vertical distance, up and down, to the change in the horizontal distance, left and right. And that's why you have the y's subtracting on the top and the x's subtracting on the bottom. There are 4 types of slopes that we can have: positive, negative, 0, and undefined. A positive slope looks something like this. It rises from left to right. A negative slope looks like this. It is going downhill or falls from left to right. A slope of 0 is a horizontal line. Let's say that this y-intercept right here is 0, 5. The equation of this line would be y equals 5 because your slope is 0. Undefined looks like this. This is always a vertical line. Okay, so vertical lines have an undefined slope. Let's say this is negative 7, 0. The equation of this line would be x equals negative 7. All right. Parallel lines. Parallel lines have the same slope. Our symbol is parallel lines. Perpendicular lines are lines with slopes that are opposite, reciprocals of each other. So this is stuff you did in geometry last year and probably in Algebra 1 the year before, but just like to have some reminders. Here's your perpendicular symbol, definitely something you did a lot with last year. The products of perpendicular slopes will always equal -1. So just a reminder of what opposite reciprocal is. If you have a slope of 2/3, the opposite reciprocal would flip it and change the sign. So when you multiply those straight across, you will always get a -1. All right, last up, quick graphs. We have 3 types of forms that we want you to graph from: slope-intercept form, point-slope form, and standard form. We don't necessarily care which form you use or which way you graph, certainly based on the equation, some ways are easier than others. For example, some people prefer to take standard form and move it into slope-intercept form and then graph the first way I will show you. Same with point-slope form. Some people like to change this to slope-intercept and then graph. It's up to you. However, if you can graph just based on what form you're given, it probably will be faster. All right, so y equals mx plus b. You should be familiar that m is your slope and b is your y-intercept. So here in this equation, you have a slope of -3/2 and you have a y-intercept of 0, 4. So always start with your y-intercept. You're going to go up to 0, 4. And then we'll just use this slope of -3/2. That means we're going down 3 and to the right 2. Make sure you always go to the right unless you are reversing your line. Otherwise, you're going to make your line going the wrong direction. So when I say reversing, notice I'm doing this. I went every direction, or all the way I could in this direction. Now I'm going back to the y-intercept, and I'm going to go up 3 and left 2. And you should have a line that is falling from left to right. Okay. All right, point slope form. M is still your slope. The point you're looking at is x1, y1. Oops. All right, so depending on the equation that you are given in point slope form, some people are going to distribute, move the 3 over, and just graph like this. And if that's what you want to do, that's fine. The problem with this one is that when you distribute, you're going to get a 2/3 x plus 2/3. And then when you add 3, you're going to have 3 and 2/3. And no one wants to graph that. Okay, we want it to be as accurate as possible. We don't want you placing a dot at 3 and 2/3. So this is why we use the point slope method. Your slope is 2/3. We're not starting at our y-intercept. We're just going to start at another point. This is the point. -1, notice the opposites, +3. So you're just going to go to -1, 3, and then do your slope from there. Up 2, right 3. And then go back, down 2, left 3. And hopefully your line is straighter than mine. Okay. All right, last one is standard form. This is our last thing for today. Again, some people prefer to take this and move it into slope-intercept form. If that's something you'd like to do, that is fine. So in that case, we would subtract our 2x over and divide by -3. Just be careful of your signs. So you'd get 2/3 x minus 3. This one works out very nicely because your y-intercept becomes an integer value. So this is fine. If you want to do that and graph it, totally fine with that. Another quick way to do this is with x-intercepts and y-intercepts. X-intercepts, as you know, are where the line hits the x-axis. Well, what every single x-intercept has in common is that the y-coordinate is 0. So to find where the x-intercept is, we are just going to go ahead and we are going to substitute a 0 in for y. That gives you 2x equals 9. And when you divide, you get an x-intercept at 4.5. Now, this one isn't ideal because it is a decimal, but 4.5 isn't that hard to plot. Y-intercept, same idea. The thing that all the y-intercepts have in common is that their x value is a 0. So to find the y-intercept, all we're going to do is plug a 0 in for x. That cancels. And you'll get your y-intercept as -3, which would be the same thing that we found over here if you move into slope-intercept form. So 0, -3. And then this is a way to graph that only has 2 points. This is like a super quick graph. Okay. Or if you prefer, move it to slope-intercept form and up 2 over 3, up 2 over 3, up 2 over 3. And there you go. Alright, so hopefully this refreshed your memory about functions as well as graphing, and we will talk about more of this tomorrow. Have a great day.